Hello dear students. Today we will discuss about module 2, that is dewatering methods, pre-compression and vertical drains. So dewatering methods is nothing but the removal of water from the construction site. Whenever the water present in the construction site, it is not possible to start the construction work. So water is enemy for the soil strength. So we have to remove the water from the construction site. So there are different methods of dewatering systems are available, that may be by gravitational method, by using sumps and ditches. Okay, then we have pumping methods, then we have vacuum methods. Different methods are available for the dewatering. So when the soil is the coarse grain, the permeability is more, it is very easy to remove the water from the soil. But when there is a fine grained soil, clay soil, or the permeability soil is very less, so in that cases it is very difficult to remove the water from that type of soil. So for that cases we use pre-compression and vertical drains. Let us discuss about in this lesson or in this lecture about pre-compression and vertical drains. So pre-compression, what do you mean by pre-compression? So preloading has been used for many years without change in the method of application. So preloading is not a new technique, it is already been used for many years. It is used to improve the soil properties, that may be increase the strength or to decrease the settlement characteristics. Preloading refers to the process of compression of the subsoil under applied vertical stress. So preloading, by applying the vertical stress, we are making the soil to compress or soil to undergo consolidation process. When a preloading is rapidly applied to a saturated soft clay deposit, the resulting settlement can be divided into three components. As we know, the component of settlements we can classify into three categories, that is primary or immediate settlement, primary consolidation settlement, and secondary consolidation settlement. The relative importance and the magnitude of each type of settlement depends on many factors such as soil type, compressibility characteristics, stress history, magnitude, rate of loading, and relationship between area of loading and thickness of compressible soil. So all these things we have studied in consolidation chapter. So basically the consolidation is for completely saturated fine grained soil. So the type of soil is very important, the compressibility characteristics, stress history is nothing but whether the soil is under over consolidated or under consolidated or normally consolidated. Then magnitude, then rate of loading and relationship between the area of loading and also the thickness of the soil which we have to compress. Generally the primary consolidation settlement predominates, and in many cases it is the only consideration in preloading design. So in the three components, the major component is the primary consolidation settlement. So in many cases we only consider the primary consolidation settlement in the preloading design. So let us understand the meaning of preloading here. Preloading or pre-compression is the process of placing additional vertical stress on a compressible soil to remove the pore water over time. So by placing the vertical load or heavy load onto the compressible soil, so we can remove the pore water. So when you apply the vertical stress, what happens? The stress is going to increase, the pore water pressure going to increase, so that the water can be removed from the compressible soil layer. The pore water dissipation reduces the total volume causing the settlement. As the pore water dissipation takes place, the volume going to reduce. As the volume decreases, so the settlement of the soil layer takes place. Surcharging is an economical method for ground improvement. Surcharging is a very economical method which can be used. However, the consolidation of the soil is time dependent delaying construction projects, making it a non-feasible alternative. So this consolidation is a time dependent, as we know, so it takes more time to complete. The soils treated we can use for organic silt, silts and clays, soft clay and dredge material. So methods of preloading or precompression, we have mainly two methods here. So that may be by means of an embankment construction on the compressible soil or by using vacuum induced preloading. Let us discuss one by one. By means of an embankment, so on the subsoil or the soil which you have to compress, so you have to construct an embankment. Okay, so embankment construction we are doing, by that we are applying the load onto the subsoil. So the technique is simply placing of a surcharge fill that may be temporary or permanent or may be combination of both on the top of the soil that requires consolidation. The temporary surcharge can be removed when the settlement exceeds the predicted final settlement. So the temporary surcharge or the embankment we can remove when the compressible soil exceeds the predicted settlement. Once sufficient consolidation takes place, the fills can be removed and construction takes place. Surcharge fills are typically 3 to 8 meter thick and generally produces settlement of 300 mm to 100 mm. So the height thickness of the embankment we can construct up to 3 to 8 meter generally we use, and which can be produce a settlement of 300 to 100 mm. Okay, the limitation of this technique is surcharge fill must extend horizontally at least 10 meter beyond the perimeter of the planned construction. It is very important. So whenever the site restriction is there, we cannot apply this condition because the surcharge fill should cover 10 meter beyond the perimeter of the planned construction. Transport of large quantities of soil on and off to the site may not be practical. It is also one of the limitation. Surcharge must remain in place for months or years, thus delaying the construction. So consolidation is a time dependent process, so it takes more time. Next we have vacuum preloading technique. So the figure shows the vacuum preloading technique. In 1952, Tillman was the first who introduced vacuum preloading to accelerate the consolidation. It consists of a system of vertical drains and a drainage layer of sand that may be onto the top about 150 mm. So you can see here there is a vertical drains have been provided and at the top we have sand layer, okay, and horizontal drainage. So this is a top sand layer and these are the vertical drains. In this method, 150 mm sand layer is placed on the surface of soft clay. The layer is covered with impervious membrane. An application of a vacuum of 60 to 80 kPa is induced in the sand, which acts as a overload. So here we are using a vacuum pump, okay, by which we are applying the load onto the sand layer. So here we are using vacuum pump to apply the pressure of 60 to 80 kPa instead of a vertical load or embankment construction. So vertical drains are used in this method. In vacuum consolidation, the surcharge load is replaced by atmospheric pressure. So surcharge load we are not applying here, so it will be applied. So above the sand layer we are applying an impervious membrane or a layer, okay, that may be by using bentonite. So the top of the layer will be under atmospheric pressure. In vacuum consolidation, the surcharge load is replaced by atmospheric pressure. Horizontal drains are installed in the drainage layer and connected to the vacuum pump. So So this is a horizontal drainage layer, sand, and a pipe is installed, so that will be connected to the vacuum pump there. To maintain air tightness, the ends of the membrane are placed at the bottom of the peripheral trench filled with bentonite. So I told, so here we are applying the impervious layer, that may be bentonite. By using bentonite, we are making that airtight. The applied negative pressure generates negative pore water pressure, resulting in an increase in effective stress in the soil. So we are applying the pressure there by using the vacuum pump, so which creates the negative pressure, which generates the negative pore water pressure. So as increase in the negative pore water pressure, so effective stress will going to increase, which in turn leading to the acceleration of consolidation. So as the pore water dissipates, okay, so consolidation takes place. So advantages of this method is there is no extra fill material is needed. So the borrowing of the soil, making the construction of the embankment, okay, it is not needed here. The construction times are generally shorter. It requires no heavy machineries, no chemical admixture. So these are the simple advantages of the vacuum methods. So then we'll going to discuss about vertical drains. So prefabricated vertical drains, PVDs, which we have discussed in geosynthetics chapter, or simply we can say that vertical drains. In the 1930s, the first reasonable application of vertical sand drains was made in California. Vertical drains are artificially created drainage paths which are inserted into the soft clay subsoil. So these are vertical drains we are making artificially in the site. So by making a sand column or maybe inserting the PVDs, the pore water squeezed out during consolidation of the clay and can flow faster in the horizontal direction towards the vertical drains. So if you see in the figure, so this is a sand drains. So this is a sand column has been installed, that may be by rotary drilling method. Then we can fill the sand here. So sand is a highly permeable layer. So when we apply the load onto the soil layer, so the water starts squeezing out in all the directions. So a vertical direction, that may be in the horizontal direction. So at the top we are providing a horizontal sand layer. So when there is a decrease in the drainage path takes place, so water moves very rapidly. Once it reaches the highly drainage medium, so water can be easily removed. So the drainage path will be decrease, in turn the time going to decrease, hence there will be increase in the consolidation process. So installation method we can do by driving or maybe driven or vibratory method. Drain diameter may be about 0.15 meter to 0.6 meter. Spacing we can provide 1.1 to 5 meter up to 5 meter. So maximum length, so it should not exceed about 13 meter. So the combination of the pre-compression and vertical drain is an effective method of removal of water or dewatering from the fine grained soils. So here we shown here the sand drain and the sand blanket at the top, and this is the surcharge fill, okay, so which gives the effective method for the removal of the water from the fine grained soil. The use of sand drain is another way to accelerate the consolidation settlement of soft normally consolidated clay layers and achieve pre-compression before the construction of a desired foundation. So before the construction, if you want to attain the required settlement or required consolidation, this is the effective method we can use by using the sand drains. Sand drains are constructed by drilling the holes through the clay layers in the field at regular intervals. The holes are then backfilled with the sand. So by drilling the hole, we can remove the soil, then we can backfill with the sand. This can be achieved by several means such as a rotary drilling and then backfilling with the sand. The soil inside the pile is then jetted out, after which backfilling with the sand is done. So in the figure we can see the diagram of sand drains after backfilling the drill holes with sand. A surcharge is applied at the ground surface. So the combination of surcharge we can apply by making the embankment there. The surcharge will increase the pore water pressure in the clay. So the excess pore water pressure in the clay will be dissipated by the drainage, so both vertically and radially to the sand drains, thereby accelerating the settlement of the clay. So this is a very effective method by using the sand drains and the surcharge, the combination of pre-compression and vertical drains. Lastly, we have electrokinetic dewatering system. So by applying the electricity to the soil, we can make the water movement. Okay, so the principle involves inserting the cathode and anode into the soil, okay, then applying the electricity between them. So the cathode may be made up of a steel bar, may be perforated. So the water, when you apply the electric current, so water molecules start moving towards the cathode. So the water velocity profile you can see here. So the H plus ions are attracted by the cathode, so the water start moving towards the cathode. Okay, so we can connect the cathode to the pump. So the cathode may be made up of a steel bar with perforated. Okay, so the perforation, through the perforation water can move to the cathode. Okay, it will be collected, then it will be pumped out there. Okay, so this is a simple electroosmosis method, water transport from anode to cathode there. So this we already studied. So this is electrokinetic dewatering method, very simple method. This is the end of the session. Thank you.